Hi, I'd like to talk to you about our flagship hydraulic training system, the MF102 series. We manufacture 3 iterations of this particular trainer. We make the model MF102-H, which is designed for teaching a 40 hours plus course in fundamental hydraulics through any level of hydraulics one wants to teach, up at a university level, mechanical engineering, etc. We then build a second version of it, the H-TS. The H-TS has the same capability for teaching fundamental through advanced hydraulics as the Model H, except we now have full course, 40-hour plus course in teaching hydraulics diagnostics and how to performance test hydraulic components. And then finally, we make the TSE version, so it's now a 102-H-TSE, and that is, the TSE acronym is Troubleshooting Electronic. This is the TSE version we're looking at right now, which has the 19-inch full-color touchscreen. I'd like to talk about the features and benefits. This is arguably the most advanced hydraulic training system in the world. And the reason why I say that is because, very briefly, I did a 10-year study of leakage rates in hydraulic components due to wear, and I took those exact wear rates in hydraulic components and we designed them into every component on the simulator, meaning that every component on the simulator can fault out, let's just say wear out, quote unquote, in real time. So let me start by talking about the components on the simulator itself. We start out with a pressure compensated. The pump is designed to roll out from underneath the tray, which gives the student the opportunity to learn how to do setups, adjustment, and troubleshooting on hydraulic pumps. The pump is an axial piston pressure compensated pump, which actually we have been able to manipulate so that we can teach in a fixed displacement hydraulic system environment, on a pressure compensated pump environment, and with an optional controller, we can go to a load sense environment. So we can teach all 3 environments on one trainer. The pump is rigged up for students to be able to do case pressure testing, inlet restriction testing, and RPM, all non-invasively. So rather than bury the hydraulic pump in underneath the trainer or drop it into the reservoir where the student has no access to it at all, we make the pump completely available because students have to learn how to do vital setups like pressure compensated settings, standby pressure and load sensing, flow settings, etc. The hydraulic hoses are also roll out from underneath the trainer, and we have hydraulic hoses, and we also have all of the T's, so that if we need to put a pressure gauge in the line, if we need to build a circuit, the T's are very conveniently located there. This is what we call zero leak. Every single connector, let's put it like this, 99% of the connectors or the connections on this trainer are O-ring seals. In other words, we practice what we preach. If we want a clean environment, if we want to build clean machines, what we need to do is design hydraulic systems that are conducive to cleanliness, and so that's what we strive to do. There's no oil drip tray, there's no catch tray, there's no need for consumables. This is a completely zero leak unit. The other thing that you'll notice is everything that we do is safety based. And so we have lockout, tag out. The students will learn lockout, tag out. The quick disconnects, you'll notice that the female, we use zero leak flat face quick disconnects, but you'll notice something unique, and that is that the female part of the quick disconnect is on the valve, not on the end of the oil transmission line. We did that because after conducting a 2-year study of quick disconnects, we found that the least likely side of a quick disconnect to remain open is the female side. And since the student is directly in front of the simulator, we decided to minimize the possibility of a student getting struck by hydraulic oil, and by putting the female part on the panel rather than on the end of the hydraulic hose. We have here the 3 pump environments. Well, this one is plugged here because this trainer does not have the optional load sense, but we also have the fixed displacement pump and of course pressure compensation. Now this manifold, again, we have a 4. This comes with a total of 7 valves. So you've got 4 bang-bang type solenoid controlled valves. Here, these are the controllers for the valves. So again, these are actuating the solenoids. The way we are able to develop a trainer that has both fixed displacement pump environment and pressure compensated is we divide the manifold. So the first valve on the left is an open center, or if you will, it's a series system. The other 3, which would typically operated in a pressure compensated or load sensing environment, are in a parallel manifold. And so we've got 4 different types of center configurations in our valving so students can learn about all the different center configurations. So when we are doing open center circuits, if you will, P and T are hooked up to the left side of the valve. And when we are doing pressure compensated and load sensing circuits, we go to P and T on the right-hand side of the valve. On the left-hand side, we have our return lines to the reservoir. There are 2 returns to the reservoir here. For convenience, the oil filler is on the left-hand side for the hydraulic tank. The oil filler is on the left side above so the instructor doesn't have to climb in under the trainer to try to get oil into the reservoir. One thing that's very important to note here is that when we sell a dual-sided or when we bid a dual-sided trainer, you actually get 2 trainers. We've seen in the past where schools have actually bought a dual-sided trainer not realizing that there's a single power unit that is either splitting the flow, which means you can't start one side without the other, or the student has to quick disconnect from one side and connect to the other. These 2 sides on a double-sided trainer are completely autonomous. The only thing that they will share is the hydraulic reservoir. All right, so let's move on up here with the components. We've got a high-pressure ball valve here. We've got a check valve. Here we have a pilot-operated relief valve. Here we have a direct operated relief valve. And then, of course, we go up to this valve, which is a sequence valve. Here we have a pressure-reducing valve. And last but not least, we have a counterbalance valve, all members of the pressure control valve family. Down the right-hand side here, we have a restricted type pressure compensated flow control valve. Here we have a flow control valve. And down below the flow control valve, we have a needle valve. We also have a hydraulic motor which has legitimate variable speed, variable torque capability. And when I say legitimate, I mean we're not spinning a flywheel, because there is no way if a trainer has flywheels which the students have to interchange, there's no physical way of seeing a pressure difference or pressure variation on the weight difference of flywheels. It's just not possible. What we actually do is we have a belt and we drive another motor behind this motor, which we can load from this side of the panel. So we can legitimately load the motor, which is obviously helpful, especially when we do motor diagnostics. So that is a unique component of our training simulators. The TS model comes with a small touch screen, and what we have on the touch screen is a numerical touchpad for the fault insertion. And that is also student driven. There is no need for the instructor to disappear behind the trainer to insert a fault. It's all student driven. So for example, if we give the student an activity and let's say there's a vertical downdrift on a cylinder, then what the student will do is build that circuit. Once the circuit is built, the student has set it up, set the valves, etc., then what the student will do is be given in the student activity book, the student will be told to, for example, select 7, 9, and 11. Obviously, the defect will be there, the cylinder will drift in real time, but the student won't know which number corresponds to the actual fault, which of course is a benefit because you don't want the instructor running around trying to figure out which switches he or she has switched, etc. And so that is student driven. We did that on purpose. This is a microleak test pump. This is microleak testing is something that I personally developed 2 decades ago. And microleak testing allows a student to test 98% of the components in a hydraulic system with the system safely locked out. It's almost non-invasive. Each test will average about 15 minutes in the field, we're talking about 15 minutes. There's no need to disassemble or remove a component in order to perform a microleak test. Again, let me remind you that every single component on here can morph from good working condition to worn out, and that's in real time. We pride ourselves also in the length of the cylinder stroke, and that is that when simulators have very short stroke cylinders, there is a problem when it comes to seeing dynamics, meaning when the student is looking to study pressure differential, when the student is trying to set, for example, a sequence valve, as soon as the student hits the control for the valve, in a split second, the cylinder just comes to a stop. What we pride ourselves in doing is giving students adequate time based on the length of stroke in order to have the time necessary to see pressure differential and to make those adjustments. In addition to loading the motor in real time, we also have legitimate load on our cylinder. We have a weight down below that when the student shifts this latch, it will latch onto the weight and raise the weight into the air. Having that capability also means that we can learn counterbalance valves because we can set them in real time. We can learn how they function. And we also have a pilot operated check valve which we attach directly to the cylinder, which is typically how it would be connected in the field on an actual machine. We do that for 2 reasons. One, obviously to learn and understand how they work, why they're there. But 2 is, one of the important things about diagnostics is, if I've got a vertical downdrift on a cylinder, I have to discern where the problem is. Is the problem the seal in the cylinder that's leaking, or the counterbalance or pilot operated check valve that's leaking? And so this gives me the ability to actually be able to differentiate between the problem being in the cylinder or the problem being with the valve itself. That is, again, a huge feature. Another very unique feature of the trainer is the flex plate. The flex plate is a great add-on because it gives instructors the ability to grow the simulator. For example, if an instructor wants to teach a particular type of valve, all the instructor needs to do is buy a special plate that they can adapt the valve to, and it will just clip literally onto the flex plate. Let me demonstrate that. Here is, for example, what's called a typical mobile directional control valve. I want to do an activity with this particular valve. I simply connect it to the flex plate and it's ready to go. It's not going to fall off. It's secure. I don't have hoses going across to a bench. It's a safety feature. If the valve needs power, so for example, here is a valve that needs power, then all the student's going to do is connect it to the power source, lock it into position, and all I do is I engage the button, and of course it engages the solenoid to activate the valve. So this particular valve gives us the ability to actually build a legitimate regenerative circuit. The simulator comes with a complete curriculum. In other words, we've got a complete curriculum for pumps, directional valves, pressure control valves, etc. The student workbooks are amazing. They're fantastic. There's just no end to the numbers of activities that the students can do on this trainer. Let me talk a little bit about pressure and flow. Our trainers are designed to plug into a standard 115 volt receptacle. 20 amp will run both sides of one trainer. We run 1 GPM at 1000 PSI. From time to time, our competitors tell our prospective clients that our pressures are too high for students that are learning. Well, let me just say something about that. The students are going to graduate from college at a low pressure, let's say 500 PSI, and they're going to go and work in the industry, and they're going to be faced with 3, 5, 8,000 PSI. I don't think there's anything harm in introducing a student to relatively high pressures in a lab. In fact, I think it's quite healthy. With respect to flow, we keep our flow down. We don't go to 3 or 5 GPM, because when you start running high flow rates, everything's running too fast. In other words, the student doesn't get a chance to set valves, etc. When the pressure settings of 500 PSI, once that severely limits the student's ability to build interesting circuits. For example, if I build a sequence circuit, just liquid resistance alone is going to consume almost 600 PSI. Regardless of what anybody says, we're running through quick disconnects, they're highly restrictive, there's plenty of them, so we can't help but build a lot of system resistance. So having 1000 PSI at 1 GPM means I can build any variety of systems, and I have no problem with overcoming both load and liquid resistance. So that's something that I would highly recommend, is we run as high a pressure as possible and keep the flow down, because what we don't need, what do we need a lot of speed for? Pointless, it's not necessary. The other thing we've put on here is we've got flow control valves under each one of our directional control valves in our parallel manifold, and that gives the student the ability to learn about not only setting up systems like pressure compensated pumps, where advantage is that you can run multiple actuators off a single pump, but it gives the student the opportunity to learn how we set these valves and how the oil is distributed through the system. And so this lets me build actual pressure compensated circuits as we'd see them in a typical mobile or industrial application. We are not a manufacturer of hydraulic components. We are an educational facility. I am a teacher. I teach hydraulics, and most of what you see, our products, were developed in my classroom. In other words, when I saw a student was battling to learn, understand a concept, all I did was go back to work and got with our design team and said, what solution can we develop to enable students to better understand a topic? Not being a manufacturer is a great advantage, because we are not locked into using all of one manufacturer's components. We go out and we seek the best of the best from the most notable manufacturers in the world. For example, all of the cartridge valves on our products are made by Sun Corporation. Sun is one of the most well-respected manufacturers of cartridge valves, not only in our country, but in the world. So we buy and we install what is good. The other thing you'll notice is aesthetics. Our young students grow up listening to our president talk about how we are the most technologically advanced country in the world. They hear it from their parents, they hear it from their mentors. They see F-35s, they see F-16s, they see the phenomenal technology that our country produces. I just don't believe in putting a student in front of a simulator that is square tubing welded together. In other words, we want the students to look at our simulator and say, this is what I expected in my classroom lab, because it's synonymous with who we are as a country. So we go for aesthetics, as safety, of course. We're unprecedented in the area of safety. And for those folks who are buying simulators, I highly encourage you to help us out. In other words, write a safety specification. It costs us 15% more to build, to include safety in our trainers, about 15% more. If we're selling on a low bid, and I understand that, I get the low bid problem, I don't have a problem with that, it keeps everybody honest, except one of the things it does when there isn't a safety specification, it means we are not going to be the low bidder purely on the basis of the fact that we have invested so much in safety. We care about, first of all, the safety of a student in a lab. Second of all, we care about the liability that the colleges have to carry. And third, of course, we don't want anybody that is using our products to get hurt. To that end, you'll also find on all of our trainers what we call safety bleed valves. These are safety bleed, also a product that was developed by us. Now, one of the problems of using quick disconnects, for example, and instructors will know this, if I connect up to a sequence valve, for example, a student connects up to a sequence valve, after all, we are learning, we are going to make errors, that's the whole purpose of learning, and so we learn to not make these errors, because hydraulic components are very unforgiving. What will happen if a student connects to port 1 and port 2 but omits to connect to port 3, which is of course your external drain line? This valve will hydrolock. There is no way in. Well, we teach in safety that two things that a student or anybody that works with fluid power must not do. Never back a connector out under pressure. All right, that's number one. Number two, I have heard, cannot substantiate it, but I've heard of cases where when a quick disconnect, a hydrolock, the student was told by the instructor, and again, this is speculation, to put a rag over it and strike it with a hammer, and that will release the hydrolock. I'd like to think that that was pure speculation, and that's not what instructors are teaching students how to do, or at least showing them what to do. In other words, I think we as instructors have to understand that whatever we do, we give our students permission to do. What we did was we understood that this is a possibility, so we put safety bleed wherever there's a potential to hydrolock a component. All the student has to do is retrieve a special safety bleed transmission line that comes with the simulator and will non-invasively take away or remove the hydrolock condition, meaning I go from red with a special device down to blue, which is a discharge zone, and I automatically de-energize. Notice the safety bleeds are also on the cylinders, because it's also important for students to learn that there's technology out there that allows me to air bleed on a closed loop, meaning I never go to atmosphere. So in other words, anytime we try exhaust oil to atmosphere, we're exposing ourselves to burn injuries, to oil injection injuries, etc. So that gives us somewhat of an overview of the simulator itself. We also pride ourselves in instrumentation. One of the most important things we can teach students, of course, is what instrumentation fluid power technicians need, and of course, how to safely use them. In this department, we are extremely generous. In addition to having dual analog flow meters standard on a trainer, we also have 3 individual pressure gauges. One of the reasons why we individualize pressure gauges is because that's what students are going to be doing in the field. In other words, if we just put a gauge panel up on the simulator, which would be easy to do, and then we were to take lines down to wherever we wanted to monitor pressure, the students will be constantly searching back to see which pressure gauge is reading what source. What we look at is, okay, what are we going to actually be doing in the field? The student in the field will be putting the gauge right where he or she needs to read the pressure. So we have 3 pressure gauges, which in the, of course, circuit, in the activity manual, the student will then place exactly where the student wants to see the pressure. On the touchscreen, on the small touchscreen, we have ambient temperature, oil temperature, RPM, that's electric motor RPM, amps, and of course we also have a built-in stopwatch. So this is pretty much the 102 and all of its features and benefits. Let me move now. Oh, by the way, we can also do, in troubleshooting, we've also got faults into the solenoids. So there's also electrical training here. Before I move into the troubleshooting aspect and briefly, notice that there's two levers here, one on either side. These are for growing the simulators because we build a variety of plug-and-play modules that simply slide into the side of the trainer, and we have power receptacles that are already there, dual 24-volt receptacles, and this is where we would just add. In other words, I can make this heavy into industrial, heavy mobile, so I can get, for example, accumulator with a differential pressure unloading. We have proportional, we have servo, we have position feedback that'll clip onto the horizontal cylinder. We can convert this into an aviation trainer. We've also converted into a wind turbine trainer. We have it in marine training centers. It is extremely versatile. So you can actually even put your own valves on. We built one for a manufacturer where the manufacturer actually sent us their valve. We actually made the valve so you can fault within the valve, and then of course it slides into the panel on the trainer, so they're teaching their own technicians their own valve. Now, let's go and focus on the touchscreen for a moment. On the touchscreen we have a number of, on the main menu we have basic hydraulic schematics. So for example, if a student's doing an activity, let's say the student is doing activity number 4, the student will, here is the circuit for activity number 4. We do this because if the student is using the handbook and is, let's say, 5 or 6 pages into the activity, and the student has to refer back to the schematic, instead of constantly going back to find the schematic, he or she can just look up and see the schematic right there. So that's very convenient for the student. So they're constantly seeing the schematic. So the way the program is designed is each trip to the simulator is 10% new information and 90% reinforcement. So the student's learning about the symbols, the student's learning about the components, interaction. You can also see that we go to great lengths to mark the components using the standard markings of that particular manufacturer. And those markings are reflected on the diagrams. Now when we go to troubleshooting, let's go back to the main menu. We have 2 levels of diagnostics. The first level is basic diagnostic activities, and each one of them features an actual machine. Meaning, as we go through the troubleshooting course, the student will learn how to test, for example, pumps. Then the student will learn how to test directional control valves, pressure control valves, cylinders, etc. Each time the student learns, or the instructor demonstrates a test procedure, for example, on a pump, and gives the student an assignment, the student will then go up and will have an actual problem that they have to take care of. It's, in this case, a punch press hydraulic system. Operators complaining that the clamping mechanism is slowing down after the machine has operated for a few hours. Well, the student will then build the circuit, getting the screen here. They'll build the actual circuit for that machine. Now, another unique feature of the trainer is that the instructor can program the simulators to either have a fault or not have a fault. In other words, it would be boring if we had 2 or 3 or 4 simulators in a class and each or all the students' results were the same, meaning all of the outcomes were good. Because in this particular instance, I don't only have one suspect component, I have more than one. This means that the student, the instructor can program this side of the simulator to have a fault in the pump and the other side no fault at all. So when the students are done learning how to fill out the graphs and graph these tests, which professional technicians need to know how to do, when they can compare notes. So they can say, well, this is what a good pump looks like, and this is what it looks like when the pump is bad. All right, so this gives you a variety of activities that follow each troubleshooting situation, meaning I've learned now how to test directional valves, pressure controls, valves, cylinders. Then we can make it even more interesting because I can go back to the main menu, go to Advanced Diagnostics, And here we have a variety of actual circuits, half of which are industrial type machines and the other half which are mobile. So let's just take, for example, a situation where you've got a front end loader. We took all of the most common problems that you would experience with a front end loader, namely in this case we have a raise and the bucket is drifting down, as an example. The student will actually build the exact replica of that circuit using a 3-section mobile directional control valve that is loaded, cylinder port relief valves, anti-cavitation valves, load check, everything. The student will build the actual circuit and then hit the next screen. And on the next screen, it will engage the fault. So once again, the student has again exercised setting the valves, setting up the circuit, etc. And now the fault is engaged. That means when the student lifts the load and goes back to neutral on the valve, the cylinder will be literally drifting down in real time. This has an algorithm in it where it's tracking the student. So we can do competency testing, we can do, let's say, end of term testing, where you want to test a student's skill sets. So what happens here is, if I give the student a 45-minute assignment here because I believe this is a 45-minute activity, then what the student will be doing is getting graded on 45 minutes, meaning if I'm going under, I get credit. If I go over, of course, then I get penalized. The next thing it's going to do, there are only 2 suspect components if I got a vertical downdrift, the cylinder and the directional control valve. That means I've got 2 attempts. If I make 1 attempt, in other words, let's say I test the directional control valve and I find the directional control valve is not defective, it automatically defaults to the cylinder, which means I only had 1 attempt, I get credit for that. However, if I go over, in other words, I'm not thinking it through properly and I start touching other components. In other words, as it functions, when the student tests, for example, the cylinder, and let's say I find the cylinder is leaking internally, if I touch the cylinder symbol on the screen, it replaces the cylinder. It's as if I went and purchased a new cylinder or I had it serviced and I replaced it. So the instructor can see the student's progress either here, or since this is a wireless touchscreen, the instructor can also observe what the student's doing from his or her desk. All right. Now, what we can do once the student has completed the activity, let's say the student touches every component, or if you will, replaces every component in the system and goes finish. Well, it says the system is fixed, and obviously it's going to be fixed. He replaced every single component in the system. Now what the instructor can do is go back into the instructor login here, and the instructor can actually go and pull up that activity the student just did, front end loader, and the instructor can see that the student had $2,000 in actual costs related to component replacement, which was $6,000 over. In fact, if this, in the hands of a manufacturer, the respective manufacturer can actually put the actual costs of a given model into the computer, and the student can actually see how much when we are not troubleshooting precisely how much money this costs in terms of labor, in terms of unnecessary component replacement. This, in developing this trainer, what we did not realize it would do is how it would create a thinking skill. In other words, if this teaches a student nothing else in terms of troubleshooting, it teaches a student how to think the problem through, because thinking is always better than doing. So it sure costs a lot less money. So that's an overview of our model MF102. You can see more on this trainer on our website. If you need more information about it, please contact us. Again, we will be featuring additional videos on other products we manufacture. So for now, any more information on the 102, let us know. Thank you very much.